All right, chapter 13, our third video is going to talk about ways to make experiments a little fancier rather than using a completely randomized experiment. Another time is to do a block experiment or blocked experiment. Blocks are very similar to strata from the stratified sampling technique. So to create a blocked experiment, there is lots of steps. Okay. So before randomization happens, people or objects are placed into blocks. They are placed into those blocks based on a variable that might influence the results of the experiment. I put right here, there's reduced variability within a block. We'll look at that in one sec. Examples of things you can block by. Sometimes experiments are blocked by age. If you think age might influence results, maybe put younger people in one block, middle-aged people in a block, and maybe senior citizens in a block. Maybe you think gender will influence results, so you would put males in a block and you'd put females in a block. Prior health history, maybe you've got people that smoke in one group and people that haven't smoked in another group or have no history of smoking. So the variable will be given in the problem. Something like researchers believe that your family history of cancer might influence the results. So you would want to block by, does your family have cancer in its history or not? It also might say in a problem something like, researchers took a group of volunteers and split them into groups based on the amount of AP classes they have had in the past. So that would be a block. Maybe you've had 0 to 1 AP class, 2 to 3, 4, and more. So you can't randomize into these things. You can't randomize someone's gender. You can't randomize someone's age. You can't randomize and say that you've smoked before and you haven't. So blocks, the creation of blocks happen before the randomization. So here's a little picture of that. So this would be a flow chart for a blocked by gender experiment. So again, we've got our subjects or our volunteers. They have not been randomly assigned. So you can see right here, there is no randomization into men and women. So this would be a block of women and a block of men. Then we basically run side-by-side experiments. This looks like we're watching 3 different advertisements and we're seeing how people respond to those ads. So whoever made up this experiment thinks that gender, a person's gender will influence how they respond to these ads. Maybe they're testing a Super Bowl ad, something like that. So we've got up here, our women are randomly assigned into the 3 groups, 1, 2, and 3, to each watch 3 different ads. There's 3 treatment groups. The men are simultaneously randomly assigned to watch those same 3 ads, the same 3 treatment groups. So we have 3 treatment groups amongst the women. We have 3 treatment groups amongst the men. We've got compare reaction amongst the women up here. We've got compare reaction among the men down here. Some people in the past have drawn another arrow comparing the reactions with men to women. You do not need to do that, and that's not actually right. The entire point of doing a block is that you think women and men were going to respond differently. So if you think that men and women are going to respond differently, there's no point at the end to compare men and women. You've already established that you thought they were going to be different. So you're in a block only comparing in this case, the blocked genders, women to women and men to men. The other card had this thing written down about, there's reduced variability within a block. So what does that really mean? So variability is variation, how varied groups are. It says if you use a block, we have reduced variability in a block. So if you just had a whole bunch of subjects go try ads 1, 2, and 3, the group 1 trying ad 1, if we had not blocked, could have been men and women. And then in group 2 with ad 2, there probably would have been a mix of men and women. Same thing with add 3 and group 3. So as soon as we made these blocks, each of these groups, they're all women. So there's less variation in these groups than there were when they could have been jumbled up with men and women. So there's less variability in these groups since they're all women. There's less variability in these groups because they're all men. If we hadn't blocked by gender, the groups would have been more varied. So that is the generic kind of blocked experiment. Then we go into two special types of blocked experiments that are called matched pairs. So two types of matched pairs experiment. It's a type of blocking. So how matched pairs works, there's actually two options. One of them is like it sounds, pairs, there's two. So let's just flip it over because I know that's option 2. Okay, so option 1 is that you try all your treatments. And we talked about that in yesterday's video about the Oreo cookies. You're your own control. You try the orange flavored, orange middle of the Oreo cookie, and you try the regular Oreo cookie, and hey, do you have a preference? You would be blindfolded. Oh, we're just going to keep going. You would be blindfolded. You would see which one you like better. So that's one type of matched pairs. You're trying both treatments. Another type of matched pairs is more like how it sounds. So you're getting paired up with someone similar to you in all ways that you can think of, except that one person or object is getting treatment 1 and the other person is getting treatment 2. So the classic example of a matched pairs experiment would be to get twins and have one twin try one treatment and randomly decide, which twin gets which treatment. Twins have grown up in the same environment. In theory, they're genetically, depending on if they're identical or fraternal. But anyway, so you kind of get the idea. They've got the same medical history, things like that. So match pairs, that's kind of the classic example. If you have a whole bunch of people, they might say, we want to pair people up based on age. And then you would put closest ages together. Or maybe they say, we want to match people up based on GPA. Then you would put closest GPAs together and the next closest GPAs together and the next closest GPAs together. And you have all these little blocks of 2 for matched pairs. So that's why it's a special kind of block. It's just got 2 people in each. For this option, there's 2 people in each block. And again, it would be randomly decided who gets one treatment and who gets the other. They are playing some very loud music in the hallway. Exciting. Let's see. The last 2 things of chapter 13 are what can go bad in experiments and observational studies. So bias is bad when we did sampling. There's also bad things that can happen in observational studies. So lurking variables are present in observational studies. So again, they're bad. Lurking variables are not good. I kind of think of them as lurking in the shadows. So basically, there's some third variable that's influencing each of the other variables being studied, and you no longer know. So here's my picture. So you're hoping to see that A influences B. A has some kind of an association B. In observational studies, there is an occasional third variable. So in our third variable, like variable C, C influences A, and then C also influences B. We weren't testing C. It wasn't part of our thought process at all, but this variable C is influencing both. So we think that A is influencing B, but really it's this third lurking variable that's influencing both of them. It'll be easier, hopefully, when we see some examples. So lurking variable is some third variable influencing both. The lurking variable can't be one of the 2 things you're studying. It has to be some third variable that influences both. So lurking variables are bad in observational studies. We'll save the classic example for class. Then we've got confounding variables, or confounding, like, is there confounding present? So confounding is bad, but in experiments. So confounding happens when you can't tell if the changes you see in groups are due to the treatment or due to outside not studied variables. So if you accidentally design an experiment and you don't keep the groups exactly the same other than the treatment, and you perhaps have included or introduced some outside not studied variable, that's bad, and that's called confounding, or the results have been confounded. I kind of think of the Confundus charm in Harry Potter, and now the results are confusing. I can't tell if my response variable has happened because of the treatment or because some other variable that accidentally got introduced. So those are the two ways that experiments and observational studies can go bad. They give them different words. And we went over blocked experiments and then the special type of blocked experiment, which is matched pairs. That concludes all of the vocabulary for Chapter 13.